Okay, so this question is fairly complex question. They've got this polygon, this right. It's got several sides called out a polygon. So, and they want us to find how many squares fit inside this entire polygon. We could try to count them. We could say, well, here's one square, two, three, four, five, six, seven, eight. Hey, let's estimate. Let me just estimate. That's eight. Here's almost nine. Now I can fit nine entire squares, but then the rest are going to be like parts of squares. Let's estimate. That's nine. This is like, I don't know, about 10. Maybe these two make 11. These guys make 12. And the rest make about 13. I'm going to estimate about 13 squares. See how I did that? I just kind of estimated. 1, 1, 1 here. And then I think there's 10 on the inside. Yeah, 10 on the inside and 3 around the edge by just a little squishing together. So that's not the real answer. This is not, you might think, that's crazy. Is that how we do that, Mr.? No, this is really not how we do this. I'm going to do it exactly. But ahead of time, I think it's helpful just to get a nice little ballpark estimate. It's helpful, especially when you're taking tests, just to have a general feel. The answer should be somewhere around 11, 12, 13, 14. If I get an answer 57, I know I've done something wrong, for example. Or if I get an answer like 2, no way. The answer is about 13. It might be 11, it might be 12, it might be 13, 14, 15. I don't know, somewhere in that neighborhood, right? Can we all agree with that? I'm just looking at how many squares approximately fit inside of that shape. And I just simply counted squares. Looks like there's 10 whole squares and then little squishy parts of extra squares, 3 of those. Well, about 13. Like I said, it's not going to be exactly 13. It might be 11, 12, 11.7, 12.3, 13.9, 14.6. I don't know, but it's not like 21. It's not like 4. No way. If I get those kind of crazy answers, I know I've done something wrong. That's why estimation is helpful. It's just, in case you hit the wrong button on your calculator, use the wrong formula on accident, it helps you, especially during tests. It's a good skill. And it's a good skill to pass on to younger folks that you're going to teach, is to approximate an answer in a math or science question. Have an approximate answer before you dive into the actual answer and formulas. Okay, enough with the approximation. How do we really do this problem? Well, we got to do all the triangles. Let me fill this one in right here. Boom. See, if I put that side in right there, see how they're asking me about triangles? They're saying find triangle ABC. See how that breaks it? Here's triangle ABC right here. And then they're going to say, then find triangle CDE, which is right here. And then find triangle EFA, which is right here. You see, it's 3 triangles, right? And we know how to find the area of a triangle. If we just find the areas of those 3 triangles, and then the end, we'll just add them up, and that'll be the whole polygon. So by adding in this line right here, this line right there, I've broken the shape into 3 triangles. So let's find the area of those 3 triangles. Okay. How do we find, excuse me, the area of triangle ABC first off? So ABC, let's do that one. So triangle ABC, which is right here, this triangle right here. I want to start with him. How do we find the area of a triangle? Now, you know the area of a triangle is just, it's base times height divided by 2, or a half times base times height. Either way, it's the same thing, right? Dividing by 2 is the same as multiplying by a half. It doesn't matter. Write it again better here. Okay, anyway, so either one of those is going to work fine. So I need to know base and height. So, okay, now how do you, so base can be any of the 3 sides. For example, could I make this the base? Well, and then this will be the height here? No, that's not going to work. Do you see why? Because this angle between them, draw that a little bit better. This angle right here is not 90 degrees. Remember, base and height have to be at 90 degrees to each other, don't they? right? If you were standing on the ground, here you are. This is you. You got a big head. I'm just joking. You're standing on the ground. You're like, hey, I'm gonna measure my height, all right? And you go diagonally down to the ground. If you did that with your friend and you said, hey, I measured my height the other day. I went to the ground diagonally and I was like 10 feet tall. I'm ready for the NBA, right? Now your friend would say to you, that's not your height, right? And or you would say, if your friend did that, you would say to your friend, that's not your height. Why not? I went to the ground. Well, you have to go, we all know, your friend knows, and I know, you have to go straight down to the ground, 90 degrees. You have to go straight down to the ground. That's what height means, doesn't it? Straight down to the ground, straight down to the base. Height and base have to be at 90 degrees, or it's not height. It can't be diagonal, can it? So that's why this cannot be the height with that base, because that angle there is not 90 degrees. See, that looks like more than 90, doesn't it? That's not 90. Okay, well then, how do we do this? We put this side back in there. There we go. Anyway, so you have to pick. So for base and height, let me write this up here for you. Base and height. So four base here. I'm changing this. For base and height. Use sides that are up and down, vertical or horizontal. I'll say that, vertical and horizontal, right? Use lines that are straight up and down or straight sideways, so they are at 90 degrees, right? Whenever you do base and a height, you've got to use lines that are straight up and down or straight sideways. That way you can easily make sure they're really at 90 degrees to each other. So do that. So, okay, so then let me look closer at this triangle here. So then if I go, let's say from here to here, that can be base. That's the base of the little triangle ABC, isn't it? He's on his side there. And what's the height? Well, here to here is his height, huh? Those are the two we should use for triangle ABC for his base and his height. Does that make sense? So we can just count the jumps. What's his base? 1, 2, 3, 4. What's his height? 1. Remember, on graph paper, we just count jumps. So the base is for triangle ABC. The base is for this triangle right here. The base is for the height is 1. And those are definitely at 90 degrees to each other, aren't they? Base and height have to be at 90 degrees because that's what height means. So use sides that are straight up and down and straight sideways, vertical and horizontal, so they're at 90 degrees. So the base, what was it? The base is 4. 1, 2, 3, 4. Height is 1, so it's 4 times 1, but then you get divided by 2 because a triangle just uses up half of a rectangle. So that's 4 divided by 2, that's 2. So that means there's 2 squares in triangle ABC. Exactly 2 squares in triangle ABC. That looks right, by the way, doesn't it? Look at this right here. If I take this is 4 squares. And it looks like the triangle ABC here is using up about half of that. 2 squares. That makes sense. So far, so good. So that's 2 squares. Okay, let's now do triangle up here. Next, CDE. So that's the triangle right there, CDE. So base and height, again, this will be base right here. And this will be height right here. For that little triangle, because they're at 90 degrees. Again, using sides that are straight up and down and straight sideways. So that is going to be base times height. So that's just 1 times 1 divided by 2. That's just 0.5 on your calculator. 0.5. So 1 times 1 divided by 2 is just 1 divided by 2 is a half, is 0.5. And that makes sense, doesn't it? That little triangle is using up exactly half of a square, isn't it? He's using up half of a square. Half of a square. So that's triangle EDC is using up half a square. Base times height, straight up and down, straight sideways. Okay, last one, triangle EFA. EFA right there. So what's his base and height? Again, got to use lines that are 90 degrees. And let me put it back the way it was right there. Yeah, so his base for this triangle goes all the way from here to here. There's his base. Okay, and what's his height? From here to there. We good there? There's base and height for that triangle. So what's his base? Count the jumps. 1, 2, 3, 4, 5. So, and what's his height? 1, 2, 3, 4, 5, 6. 5 by 6. So it's 5 times 6 divided by 2. 30 over 2, 15. Does that make sense? So for triangle EFA, there's his base, there's his height. So his base is all the way from here, 1, 2, 3, 4, 5 down to there. That's the base of the triangle. The height is 90 degrees to that right here, 90 degrees to the height. And then this is the bottom of the triangle. We're not doing these guys right now, right? It's the bottom of the triangle. So the height goes 1, 2, 3, 4, 5, 6. From the tip top straight down to the base at 90 degrees. That's the height. So 5 times 6 divided by 2 is 15. Okay, so now, so we've got, this right here is 15. We've got this little part right here is 0.5, and this little part right here is a 2. So then we just, to find the overall polygon, we just add those up, don't we? So the whole polygon, the whole shape is going to be 15, 2, and 0.5. So 17.5. And what did we think the end? Oh, did I say 13? I was pretty far off, kind of. My estimation wasn't so good, I guess. I don't know how I got such a bad estimate. Well, so much for my estimating skills. At least it didn't come out 50, and it didn't come out 3. So I guess it helped a little, but it kind of was also a little misleading. Did I say 13? That's terrible. Anyway, 17.5 is how many exact squares fit inside that polygon. You can fit exactly 17.5 squares. That's not an approximation, that's an exact answer. How many squares fit inside that polygon? There we go.